morning, peoples. Stand. Yes, up. You doing good?
Yes, I am.
So where we stopped off last time? Anybody know? You know? No, she does. Okay.
Oh yeah, I got my notes.
Let's see. Chapter, yeah. Alrighty. We're talking about capacitance today. What time is it?
10:58.
10:58. I am not doing overtime. No. They don't pay me enough around here. What'd you have for breakfast?
Had some cereal, some cinnamon toast crunch.
That's it?
Yeah.
No. I woke up this morning and was thinking about duck. Have you ever had duck?
No.
No. Duck's good.
Really? Does it taste like chicken?
Every day says everything tastes like chicken. No. Duck doesn't taste like chicken. It tastes better than, like Dallas losing. It has
Really?
a way better taste than that. I love Dallas losing, but duck is on a different level. We're talking about capacitance today. Do you know what that is? Know what that means?
Something to do with like.
No. You and Dallas must be close cousins, because keep coming up short. Capacitance, the ability of a body to store an electrical charge, which means an object can be electrically charged, exhibits capacitance. Now, for our first example, there's two ways you can do this. So first type of capacitance we're going to talk about today is series. When you take the series, you take the value of the capacitance and you inverse it, and you add them together. So in this first example, as you see, capacitance 1 is measuring at 2 microfarads, and the other one is 4 and 8. We take the inverse of them and add them together. But for the capacitance of all three of them, you have to take the answer of all this, and you have to get it in your calculator, your little machine, do the answer inverse sign, and get you the equivalent capacitance. So the equivalent of all the capacitance is basically the summation, which is the sigma over 1 over capacitance, any of them, is equal to the 1 over the equivalent capacitance. This is only dealing with series. And this is another thing that you must keep in mind with dealing with series, is that the equivalent capacitance must be smaller than the smallest single capacitance. As you see, our answer is 1.14, which is smaller than 2. Hold on, class. Just one more. Yes, guys, this life isn't my life. I'm way more important than that. Only reason I'm here is to, store loves the kids. I have to give back to my community. But this doesn't keep the lights on. As I was saying, series, parallel, the two type of capacitance. The difference here is that when you come with this 10 volts, the charge goes through and it drops off a little here. Some of it keeps going. Drops off a little here, and the rest goes on around. And then it collects back up. Coming, and it all comes back together in this parallel circuit. So for the example, we have the same numbers. As you see in series, we took the inverse of them. Here Just add them straight up. Have 2, 4, and 8. That's what? Too long. Book answer. 14. And the difference, like I said, they're totally separate. Not really. Series, you must be smaller than the smallest capacitor. And parallel must be larger. Than the largest capacitor. As we see, 8 is the largest one, but we got 14 for the equivalent. So any questions over series and parallel?
Yeah.
Yes.
Okay, so basically you're saying like a circuit that's composed of like components like capacitors that are followed after the next, like next to each other, that's considered a series, and the capacitors that where voltage is being lost are going through different paths to the different capacitors that are on top of each other, that's parallel. That's basically
Yes. Did you see these two lines, these wires that the capacitors are sitting on are parallel to each other, all 3 of them. Whereas here in the series, like you were saying, it's consecutive, one after another after another. So yes, that's the difference in the 2.
Oh.
Any more questions?
Okay, I do have a question. So, you talked about the series and you talked about the parallel, but what if, because I'm pretty sure you're gonna do this, but what if happens if you put them together to where you have parallel and a series?
Good question. Let's look at this example. Peoples, what time is it?
11:48.
11:48. No, God put me here for a reason. Let's see if I can do this in 2 minutes. I can. Just a little different. Example 3. We have this circuit. How many volts is in it? 10, yes. I have capacitors 1 and 2, which are in what type? Parallel or series?
They're in series because they're next to each other.
You're right. Capacitance 3, which is no longer in series with these 2. 4, 5, 6, and 7. So, a way to make this beautiful, because everything in physics is beautiful, we're going to take these 2, since they are in what?
Parallel.
Yes. We're going to add them together. And then we're going to section off these 3. And they're in what?
Series.
Yes. And these as well. Series. Section off and make it beautiful. So now we have capacitor 1 and 2. 3, 4, and 5. 6 and 7. Alright, so once we combine and get a more beautiful picture, what do you think the next step should be?
Well, you can take the capacitance at the top and on the right side and calculate it in the series formula.
You're right. Beautiful, good. So now we have capacitor 3, 4, 5, 6, and 7 added up all together, as well as capacitors 1 and 2. Now we do simple math. We just added 3, 4, 5, 6, 7, 1, and 2, because it is in parallel.
Yeah.
And the equivalent capacitor will be 1.832, the book answer. So what time is it? How much time we have left in class? Quick.
It's 11:49.
Yes. So if you want to find the charge, take the equivalent capacitance and multiply it by the voltage. It's quick and easy. Capacitance is 1.832 times 10 to the negative 6 times 10 voltage. And there you go. 1.832 times 10 to the negative 5 coulombs. And that is the charge. We have learned about capacitance today, my peoples. Go home and study.